All right, we are looking at section 3.6, which is absolute value functions. Now, we have talked a great deal about absolute value already this year. We have looked at solving absolute value equalities and inequalities, but now that we understand piecewise defined functions and we've been exposed to those, we can get a better understanding of the actual definition of absolute value. Absolute value is going to be a piecewise defined function, and here's why. If what's inside your absolute value, okay, what we've got is x. If what's inside your absolute value is greater than or equal to 0, meaning it's positive, when you take the absolute value of a positive number, you just get exactly what you started with, right? But if what's inside your absolute value is a number less than 0, meaning it's negative, you're going to get the opposite of what you started with. So don't think of that as a negative. Think of it as the opposite of. Here's an easier way to see that. When you take the absolute value of 2, you just get 2. That's because what was inside your absolute value was greater than or equal to 0, so you just got exactly what you started with. But if you were taking the absolute value of negative 2, we know the absolute value of negative 2 is positive 2, but here's the reason why. If what's inside your absolute value, negative 2, is less than 0, you should get the opposite of what you started with. You should get the opposite of negative 2, which would be a positive 2. All right? So just a little more detail to our understanding of absolute value. All right, now let's go back and review some things that we already know. We already know how to solve absolute value equalities and inequalities, but let's just review that. All right, so if you have an absolute value equality, you want to get the absolute value on one side by itself. So let's subtract that 3 from both sides. And then you're going to take what you have in your absolute value and set it equal to a positive and a negative of what you have on the other side. Take what's inside the absolute value, set it equal to a positive and a negative of what's on the other side. That's going to create two different equations, and then we can just solve those equations. So, of course, over here, we're going to add 2 to both sides, and here we're going to add 2 to both sides. And you can always plug these back in and check them and see that they work. So, for instance, 4 minus 2 is 2. Absolute value of 2 is 2 plus 3 is 5. And then 0 minus 2 is negative 2. Absolute value of negative 2 is positive 2. 2 plus 3 is 5. So we can see both of those work. All right, with our inequalities, remember we talked about conjunctions and disjunctions. And we said when it looked like a C, like you can see here, the less than looks like a C, that's a conjunction, that's an and statement. When it's greater than, when it looks like a D, that was a disjunction, that was an or statement. And our little shortcut that we had was copy exactly what you have without the absolute value, copy the same sign, copy the opposite number. And since we know this is an and statement, then we want to leave this together and not break it into two separate pieces with the word or in between. And then sometimes they would have us graph our answer or give it an interval notation. And the nice thing was the graph and the interval notation kind of mimicked each other. So nothing new about that. But here's what they want to do. They want us to kind of think about some odd answers that we might get to problems like that we've not seen before. Like let's say you had a solution like negative 1 is greater than x is greater than 1. All right, let's start with this piece right here. If negative 1 is greater than x, or x is less than negative 1, I'm going to have an open dot at negative 1 and going off to negative infinity. For this other piece, if x is greater than 1, I'm going to have an open dot at 1 going off to infinity. Now, because this is all together here, it's an and statement. It doesn't matter what the signs are. The only time we do this little sign thing is when it's an absolute value. This is not an absolute value. I take this exactly as they give it to me. So because this is all together, this is an and statement. That means that my answer is only where both the green and the blue both exist. That's nowhere. They don't overlap at all. They don't exist at the same place. And so that's what an example of no solution would look like. All right, here's another kind of strange answer that we get sometimes. It says, what if your answer was x is greater than -1 or x is less than 1? Okay, so x is greater than -1 would be an open dot at -1 going to positive infinity. X is less than 1 would be an open dot at 1 going to negative infinity. When it's an or statement, it doesn't have to be where they both exist. It's where either one exists. One or the other makes it a solution. And so I put both pieces of my graph together and keep everything. And when I do, that literally would be the whole number line. If you think about what's a number that's either bigger than -1 or smaller than +1, every number is going to be one of those two things. And so that would be all real numbers. So again, even though we've spent a lot of time on the absolute value equalities and inequalities before, they just want to kind of show us here some oddities that come up in our answers sometimes and make sure we have a little deeper understanding of that. Okay, in section 3.5, we talked about horizontal and vertical shifts, reflections, stretches, and shrinks, all of those different things. And so we want to apply that to our toolkit functions. And specifically in this example, we want to apply it to this absolute value that we've been looking at today. So it'll also give us some more review with section 3.5. Okay, so remember when you're looking for the horizontal shift, it is any value that's being subtracted from x. So if you have x plus 4, that's actually x minus a -4. You also can think of it as the opposite of that number. So the opposite of +4 is -4. That's my horizontal shift. Vertical shift is any value being subtracted from y. So it might be easier to add that 3 to the other side to see it. But what's being subtracted from y is -3. Again, you can think of it as the opposite of that number. If you leave it over here on the right-hand side, you can use the number exactly as it is. All right, and then the reflection, if you'll notice, we have a negative out in front of the entire function. So that negative is going to cause a reflection in the x-axis. And the 2 out in front is going to cause a stretch by a factor of 2. So we want to apply all of those things to our graph, but there's a particular order that we need to follow or we won't get the right answer. We want to do horizontal shift and then reflection and then vertical shift. That's the most important, that we have to reflect before we vertical shift. And then I usually just do my stretch or shrink last, but you could do it earlier. That's not a problem. The key is you have to reflect before you vertical shift. All right, so if we start with our horizontal shift of -4, then we're just going to take that graph and bump it over -4. Now, you're welcome to use different colors here for each of these steps, or you can use dotted and solid and bold to show each of your steps. Just in some way, make sure you show me what you want me to do for your final answer, okay? Then the next thing we want to do is reflect it in the x-axis. And then we want to vertically shift it down 3. All right, and then we want to stretch by a factor of 2. So remember, that's just going to make it a little bit taller and skinnier. And again, in some way, be sure you indicate to me what your final answer is when I'm grading this. You don't have to show all the steps, but then I can give you partial credit if you do. And definitely don't erase off your previous graphs, because then I can't give you partial credit for them. All right, let's look at some more examples of absolute value. All right, it says, for this absolute value function, find the values of x such that f of x is equal to 0. It doesn't say f of 0. It's not saying put 0 in for x. It's saying the whole thing f of x equals 0. What's the same thing as f of x? Y. So it's telling you y equals 0. So we're going to come over here and we're going to replace f of x with y. And so we're going to replace f of x or y with 0. And then we're back to just solving an absolute value equality. Remember, you want to get the absolute value on one side by itself. For some reason, I just like the absolute value on the left, but it doesn't matter. You can write it this way or this way. So now that I have the absolute value on one side by itself, remember to take what's inside the absolute value and set it equal to a positive and a negative of what's on the other side. And now we just have two baby equations to solve. So we can subtract 1 and divide by 4 to get our answers. So over here, if I subtract 1 and divide by 4, I'm going to put that fraction in lowest terms. And then here, subtract 1 and divide by 4. So I got x is equal to 3/2. And then remember my y value is 0. And I got x is equal to -2 and my y value is 0. Now, there's another name for this. There's another name for when you set your function equal to 0. A 0 of the function, what does that look like on a graph? Well, it looks like an x-intercept. So another way they could ask this question is they could say, find the x-intercepts for the function. All right, so then they're also going to ask us to go ahead and find the y-intercept. So remember, you find x-intercepts by putting 0 in for y. You find y-intercepts by putting 0 in for x. So we're just going to take the original function that they gave us, and we're going to put 0 in the place of this x right here. So if we put 0 in for x and then we solve, we'll find our y-intercept. All right, so we could say 0 plus 1 is 1. Absolute value of 1 is 1. Minus 7 is going to give us -6. And so there's our y-intercept. So again, x-intercepts or zeros of the function, and then y-intercept.